Common NDE terms for inspectors, Module 4, Weld Inspection Mastery, the complete NDT NDE course. Gary Pace.
Okay, so we're going to just talk about some terminology here that you might run across in non-destructive examination. One of them is, we'll start with corrective action. So this is an action taken or plans for actions to be taken for solving problems that occur during production. So you might have heard of a corrective action report. So we figure out, okay, we've got this weld, there's a flaw in it, a defect, we need to chop that weld out and replace it. Well, how are we going to do that? Well, we put together a plan for this, and then we put it in documentation, and then we follow the plan. So this is called corrective action, or a corrective action report would be the actual documentation of this. Critical flaw size. This is the minimum extent of a flaw, you know, the depth, length, whatever, that is going to prevent achievement of a design goal for that part. How much undercut can we handle? How big of a slag pocket can we handle? How ugly can that weld be? What is our critical flaw size that we can live with for a particular part? Okay, so we got a defect. This is a term we're going to hear a lot. Defect. So a defect is any condition of a part that prevents achievement of a design goal. That's what we call a defect. So we can have flaws, we can have indications, but a defect is something that prevents us from achieving our design goal. You know, is this going to cause the part to fail? It's a defect. So it's a flaw that's a critical size or larger. We call it a defect. We can have a flaw, we can have an indication, but if it isn't of a specific nature and or of a critical size, then we don't call it a defect. It's just known as a discontinuity or a flaw or an indication. But a defect is something that it hits a certain size, then we've got to worry about it, and it's known as a defect.
So let's get into some of the key words that we got in this game. Discontinuity versus flaw versus defect. So with a discontinuity, this means that it's not perfect. It's an interruption or something that's just a little off from the normal structure of the material. We call this a discontinuity. Well, when we go from discontinuity into a flaw, well, a flaw is a discontinuity, and it could have possible undesirable attributes that we might have to kick. Not saying we do, not saying we don't. It could. Needs further looking at, let's say. Defect is flat out rejectable. It's got to go. We got to fix it or reject it. And this exceeds the acceptance criteria. So for inspectors, not every discontinuity is rejectable. That's just the game. It can be a discontinuity. We can notice it. We found it. We saw something was an interruption of the structure, but we don't have to reject it for it. And acceptance is going to depend on the governing code that we're working to.
Let's talk about documentation. What kind of anything in engineering would be incomplete without documentation? We got to have documentation to back up what we're doing. If it doesn't have documentation, it didn't happen. So a documentation is a written or recorded proof, usually includes a picture or some kind of other data that we can attach to our documentation package, to our report, and it gives us an idea of what happened during the testing. During a controlled test, we followed a procedure. This is what we got. Here's a picture of it. Here's an x-ray of it. Here's what we had happen. So we need documentation if we're going to do non-destructive testing and do it correctly. We can't just have random he said, she said type of tribal knowledge for, yeah, Fred over there said it failed. No, we need a written report. We got to act like grown-ups. Should include the names, the date, the equipment used, any other vital information that we have should be included in there. The name of who did it, the person and their qualifications, who did the inspection, who did the testing, so that we can confirm that the part or the results of the test happened as we say they happened. So this is all needs to be done and included in the documentation package. So names, dates, equipments, once again, gets back to we need to act like a grown-up. Okay, let's talk about the term flaw. So any imperfection in a part can be considered a flaw. And by definition, all parts are going to have flaws. So when we get to flaw size, a lot of them are just too small to be of concern. We just don't care. They're not going to affect the structural integrity of the component or the part. So we just don't care about them. They're just a flaw. They're an imperfection. They're a discontinuity. But if they get to be a large enough concern, if they're beyond a certain size, they can cause the part to fail. And at this point, we end up calling them defects. So when a flaw gets big enough to cause failure, they're called defects. So that's the difference between a flaw and a defect. Indications, here's another term. Any signal or marking obtained in a test is an indication. Indications we need to interpret. Gets back to being a flaw, so we need to interpret them. We can have false indications. Something shows up on a part or in a scan or a test, and it's like, okay, it's a false positive. It's an indication, but it's not a valid indication. So we can have that going on in non-destructive testing. And then we can have acceptable indications and rejectable indications. If it's a rejectable indication, at that point, it is a defect, and we deal with it.
So then we've got types of inspection indications. We've got relevant indications, and these are caused by actual discontinuities. Hey, this is relevant. We got to deal with this. Non-relevant indication. This could be something that's caused by the geometry or the part configuration, or something isn't right, but we don't have to fix it. It's non-relevant. We know it's there, but we don't have to deal with it. False indication. This could be something that shows up and we see it as an indication. We can see it, we see something's wrong there, but then after a while we look at it again and it's like Bigfoot. It's not there. Or whatever you want to use. We saw it, we thought we saw it, and then we looked again and we looked again and it's not there. So the important thing here is you've got to be able to utilize these words and also be able to interpret indications correctly before we get in there with a grinder or a blowtorch or something and start cutting out welds and fixing things. So we need to understand this before we make disposition decisions, because when we disposition it and the welding engineer, PACE, gets involved and we got to cut a weld out and weld it back up, that's going to cost money. And we got to do the NDE again, and we got to make sure.
So permanent record, this would be something like an X-ray, or let's say now with cell phones, we take a picture of something that's, we do visual testing and there's a flaw, a defect that we need to remove. Then we can relook at it and confirm, yeah, that's a defect that we need to take out. We need to deal with that. So just a permanent record, pictures, anything that we can have, like I say, X-rays, radiographs, something that we can use to make disposition a part, and then, or to confirm that, hey, this is good. So permanent record. And this is going to go into the documentation package that might be specified for particular inspections, depending on what we're doing and who we're doing it for. They might need a permanent record, and in the documentation package it says, yeah, you did this and there's no defects in there, or any defects there were, you guys cleaned them up and fixed them. So permanent record, very important.
I know I keep beating this dead horse, and well, get used to it. Why documentation matters? Why do we document this stuff in NDE? Well, traceability and code compliance, depending on what we're building, depending on how important it is. We probably want to have some kind of traceability. Big bridges over rivers, that if something goes wrong, somebody's going for a swim or whatever, it's going to provide evidence that inspection happened. Hey, Fred looked at this, signed off. Fred was a level 2. We looked at it. Here's our paperwork that says this happened. And then if audits or a customer review, hey, did you guys actually do this? Why did this thing break on the bottom of the Gulf of Mexico, and now we're pumping oil into the water and we're paying $8 billion a day, or whatever that is. And then for regulated industries, nuclear industry or aviation or something, or oil and gas, you're probably going to want some paperwork backing up that you did the NDE. And permanent records, we can review them years later if something goes wrong, right? We have some kind of Chernobyl or Fukushima or some kind of crazy accident in the United States, God forbid, in regard to nuclear power, we can come back and say, well, it wasn't us. The welds were good. Find a different, a different reason. Or maybe it's like, ooh, God, that we didn't do that. And then there's common types of documentation, RT film, digital images. Now that we're in the digital age and have been for years, hey, we took a picture of this. This is what we got. Inspection reports and calibration records. These are all common examples of documentation that might be kept.
Now, a reference standard would be something that we use to judge the status or acceptability of another part. So a lot of times we'll have like this stair step. We can use that to measure the radiation that's getting to a piece of film. So we'd shoot an X-ray of this, and then there'd be different levels of darkness or how light on the radiograph, and that would give us an indication of, it would give us a standard that we can work with. So a lot of times we have reference standards for ultrasonic testing. We'll drill holes in a piece of metal or put a crack in there, and then we'll find that crack. We know where that crack is, and then in that particular part, then once we get into the production, and if we find something similar, okay, we know that that crack looks like what a crack looks like because we found it on our reference standard, and we're finding the same thing here. So that's what we do with reference standards. Trade-off. And this gets back to just basic English language. Mutually exclusive events or condition that often require a choice between them. So with some of these non-destructive testing methods, there's going to be a trade-off. What do we want to do? We can trade this for this. We can, this type of non-destructive testing works really, really well, but this is what we're going to have to give up to get that. Or this one doesn't work as well as that one, but maybe it's a little cheaper and easier, but it gets us to where we need to be. So we've got the term trade-off. It's, like I said, exchanging one state or condition for another with subsequent losses or gains. So that's what we're talking about. With the different non-destructive testing methods, there are going to be some trade-offs between the different methods, depending on what your outcome is and what you can live with and what the customer can live with and what the requirements are.
So circling back around, real-world inspection decision-making. Not every flaw is going to require a repair. it might just be a flaw. We can live with it. Yeah, we've got some porosity in this weld. It's a structural weld. AWS D1.1 is going to allow you to have a certain amount of porosity in welds that other codes might not allow you to have. And repair decisions, this is cost, code limits, service conditions. Anytime we repair something, it's going to involve cost. We got to cut it out. We got to redo it. We got to depending on what we did, we've got to do the same kind of non-destructive testing. If we shot an x-ray on it and we're fixing it, we got to shoot another x-ray on it. That costs money. The inspectors, this is always gets a little gummed up picking on my fellow inspectors, but you got to follow the acceptance criteria, not personal opinion. Back in the day, I was more like a lawyer for my welders. Hey, we got to fix this, or hey, I'll go argue for you, see if we can, what we've got. Both communication and documentation are critical in this industry. If you're coming out of the trades as a welder and you're getting into inspection, you got to be able to communicate and document. And good inspection is going to help us with both safety and production. Questions, comments, thoughts, concerns? Gary Pace, PE, welding engineer, Katy, Texas.